afternoon, Madam Faizal. My name is Haikal from BMKV S2/1. Today I'll be representing my group to present about the outcome for the simulation of the heat transfer. So our main product is the GPU heatsink, in which this GPU is consisted of two main parts: the main heatsink and the plate. So these two main parts is made of two different materials, in which the bottom plate is made of copper, which has an extremely high thermal conductivity at 390, in which the high thermal conductivity will help to transfer all the heat from the CPU board into this heatsink so that the heat can be dispersed off. While this heatsink is made of aluminium, which has slightly lower thermal conductivity. So for the boundary conditions that we set for this simulation to run is that we'll be mimicking the real life scenario in which there will be an inlet velocity where the velocity will pointing downwards from for the upper heatsink. Will be flowing downwards, and then there will be a power source in which the power source will be directed at this plate at 130 watts. Meanwhile, the ambient temperature that is set is at 27 degrees Celsius, while the convection coefficient is at 20. So here I will be running the simulation. As you can see, the simulation mimics the real life scenario, in which the boundary that was set is that the velocity, the air, will only touch the upper surface, including every single surface. In here, the simulation is only done on one plane. It will only touch the whole heatsink surface of the upper area, while it does not touch the bottom half of the heatsink, because the bottom half of the heatsink will be linked to the GPU board, so it has no air flow in that direction. From here, we can see the results of the temperature. We can see here the highest temperature gain was 54.8 degrees Celsius, which is right at the bottom of this plate, where the main power was derived from, while the lowest temperature is 26.99, which is at the very side of this heatsink. Due to the massive size of the heatsink, so the temperature at the very side of the fin will be much more lower compared to the middle part of the heatsink, in which from here we can see the color gradient temperature changes from red to being very, very hot into blue, being very, very cold, while the green gradient outlines the mid temperature, which ranges from 39.35 to 45. So from here, the real life scenario is in which the heat will be transferred here, and then the heat will disperse all throughout the whole fan, the heatsink, and then the fan will blow on top of the heatsink. In which for our scenario, the RTX 3050 GPU heatsink only has one fan in the middle, so the side of this GPU doesn't have any fan directing downwards. Okay, so that will be for the heatsink simulation for our project. Thank you, madam.